Hello and welcome. In this video, I'll be talking about another interesting sorting algorithm that is called Radix sort. This sort is also somewhat similar to count sort and is a non-comparison based sort. Also, this is a sort which has a linear time complexity, and this is an interesting algorithm because it also helps us understand how to scale one particular solution um, and improvise upon. If we look at count sort, there was some limitation about, like, we needed as many numbers as that of the range of input elements to sort them. Here in Radix sort, we are going away with that limitation, and we don't anymore need the same number or like the same size array as that of the range of input elements. Example, if the numbers were from 1 to 100, we needed an array of size 100 in count sort to sort them. In Radix sort, we just need an array of size which is same as that of Radix, or the base of that input set. For integers, the base is 10, so we just need an array of size 10 to sort any numbers. One thing that we still need is the maximum number in that input set, and there's a process that we will have to repeat as many times as that there are number of digits in the maximum number. Let's look at how Radix sort works. Here I have taken some input set of numbers 98, 1, 10, 0, 22, 31, 8, 7, 7 and 100. Before we even begin the actual Radix sort working, let's look at the basic math that's required to extract one digit at a time from the right hand side of any number. Let's say if we have number 7, 1, 2 and 3. The way we extract one number from right hand side at a time is by taking mod 10, which is equal to 3, and in second case we have to first divide this number. If I want to extract 2, then I have to first divide this number by 10. 7, 1, 2. I'm just considering the integer part, and I'm just ignoring whatever was the decimal part, like I don't need this 0.3. Okay, so let's just look at 712, and I have to do the mod 10 again, and this gives me 2. I will repeat the same process again. So we are seeing, like, the number that I have to divide by is getting multiplied by 10 at every iteration. Second time it would be 71, and when I take mod it will be 1, and then again there will be only 7, and if any number is smaller than 10, then the mod is equal to that same number. So this is how I extract one number at a time out of the main number. So another second important thing in Radix sort is that we want to treat numbers that have same rightmost digit. For example, 10, 0 and 100 are supposed to be treated as same or of equal value. Of course they are not, but then this is how Radix sort works, because if we just compare the rightmost value, then yes, that's true that the rightmost value, rightmost digit is same because they all are 0. So we are comparing place value by place value, each digit of each number, and then treating those numbers same, and then putting them in corresponding buckets over here. Okay, let's see that in action. How does that work? First iteration, I'll just divide by 1, so number remains same, and then I have to take a mod of each of these numbers, mod 10. Okay, let me write down whatever the mod values are here in the first iteration. So 98 mod 10 would be 8. 1 is less than 10, so it will be 1 only. Here 10 mod 10 would be 0, and 0 would be 0. For 22, 2. Basically At the end we want whatever is the rightmost digit, so I can quickly write that down. Now we have to treat these as actual numbers. Okay, let's say that now I just want to apply a count sort on these numbers. Then what do we do in general for count sort? In the previous videos that we saw, that we just count the frequencies, then we build the cumulative frequency, and then we determine at what exact position these numbers should appear. If I just look at these numbers, they are in range of 0 to 9. So what I have done by this operation is I have bound, I know my limit, like at every iteration the limit would be 0 to 9. Okay, now I'm just going to put these numbers into the corresponding buckets. So this visualization of putting them into the buckets, which looks like an array, can be directly implemented in the code, or we can implement the count sort. Let's see that later. First let's work through our algorithm. Okay, so 98 goes here, and 1 will go to the index number 1. Then 10 has to go at index 0. 0 will also come here, and then 22 has to appear here. And Radix sort is also from the family of stable sorting algorithms, which means they will preserve the order of equal numbers. That's an important property to achieve sorting here in the Radix sort. Okay, so I have already put these original numbers in the corresponding buckets by treating their rightmost digit as same, which means the key is my rightmost digit, and the corresponding numbers have gone inside these buckets. Now I have to follow a FIFO approach, first in first out, and I have to take out these numbers from the buckets. So I'll be writing down the output over here, 10, and then 0, then 1, 22, 31, 7, 7. Okay, I missed the 100, so 100 is supposed to go here. And let's redo this part. 10, 0, and then there should be 100, and then 1, then 22, 31, 7, 7, 98, and 8. Okay, now I have to again divide these numbers by 10, take the only the integer part, and I take the mod again. So remember, like anything that is less than 10, its mod is the same. 10 mod 10 is 0, and 0 is 0. So this looks fine, and now what I have to do is, for each of these numbers, now my input set is this. So output of my first iteration becomes the input for second iteration, and I have to slot in according to these keys. Now for 10, it goes to index number 1 here. For 0, 0. For 100, I have the index 0. For 1, uh, again it's 0. For 22, it's 2. For 31, it's 3. For 7, it's 0. For 7, again 0. Sorry, I did a mistake over here. All this would be 0. Now let's continue, and 7 comes here, and 98 goes to position number 9, and 8 comes here. Now I have to again spread these numbers out in the FIFO format: 0, 1, 0, 0, 22, 31. Okay, uh, it's supposed to be 1, 7, 7, 8, 10, 22, 31, and 98. Now this time I will have to divide it by 100, because in the first iteration I divided by 1, second iteration I divided by 10, and in third iteration I have to divide by 100. And why I have to do 3 iterations? Because the maximum number here is 100, which has 3 digits. Okay, let's quickly divide this by 100, and everything here would be 0 except 100. And in this case all the mods will be 0, and for 1 it would be 1. Rest everything would be 0. I'm not writing zeros all over here. Now what I have to do is I have to again insert these numbers into the bucket. Starting from 0 goes to 0, and 100 goes to 1. And if I look at 1, 1 again goes to 0, 7, 7, 8, 10, 22, 31, and 98. Now if I take out these numbers from the bucket in the FIFO format: 0, 1, 7, 7, 8, 10, 22, 31, 98, and 100. So now we see that this is finally in the sorted order, and we were able to sort numbers by repeating the process 3 times of extracting the rightmost digit and then considering all the numbers equal. Why I say considering all the numbers equal is I'm putting them into the same bucket. I'm counting, like if I have to run count sort on those digits which were extracted out, then they will be counted by my frequency counter. Like if I have to count now like how many zeros are here, then it would be 3. So it's like either you can use the arrays to implement this bucketing sort of a mechanism, and then take out the numbers and then again repeat, rinse and repeat, or you can just take these numbers and apply count sort on it. Okay. uh, Basically in count sort we were using the actual numbers for the key and counting the frequencies. We can modify the code of count sort to just consider the rightmost digit as per the iteration it is on. Let's look at that in the implementation. I'll just copy the count sort function from my previous example, and here since we are overcoming this limitation of min max, I will not accept the range anymore. Instead I will replace it with the exponent. So this exponent variable is a representation of which iteration it is on, and based on that which place value or which digit it is supposed to extract. In our case the exp's value or the exponent value would vary from 1, 10 till 100 in the previous example. Okay. uh, and since I don't need this min max, I already know that it will be always 0 to 9, the range. So I can always have my frequency array initialized for only 10 numbers, 0 to 9. Now to build the frequency counter, I don't have to directly use the number. Instead of that, we will take the RHS, the rightmost digit. Okay. So let's say if I have to extract rightmost digit, then what I have to do is I have to take ARR of I and first divide by the corresponding value for which place value we are going to extract. In case of like at the ones place, then exponent would be 1. At tens place it would be 10. Okay, and here I have to also consider only the integer part. I don't have to take the uh, floating part of this result. And then I just take mod of 10. This would return me back the rightmost digit. Okay, and this is used to build my frequency. Okay, uh, creating the cumulative frequency. This portion remains same as it was earlier in the previous example. Now to build the sorted array, here also we need to do a little bit of changes. Uh, so instead of this current element, because current element is not the key anymore, my key is the rightmost digit. Okay, so I am taking rightmost digit and I'll be using this as the key to obtain the right position in the array. Subtract 1 because array indexes start from 0, and in the sorted array, which is my new empty array, I am putting the ARR I. Okay, so while copying and putting the values back to the sorted array, I am taking the original number, and while trying to find what is the right position, I am using the rightmost digit. Okay, and since my key was rightmost digit, I should reduce 1 from the frequency counter, and now if a similar same digit is seen in the ARRI, then its position would be reduced by 1. Okay, it's basically the same thing what we did in the count sort, but instead of the number itself being used as a key, we are using its rightmost digit. And let's write another function, radix sort, and accept array over here. Let's start with max, because this is what I need to do as a first step. I need to find what is the maximum number in this input set. And I have to repeat the count sort until there are no more digits to be extracted out of. I need to take one more variable, let exp equals to 1, and I have to only worry about the integer part here. We can safely ignore is greater than 0. Okay, till the time we are able to extract digits, we will continue doing this operation where my ARR would be count sort on ARR, and every time I will be sending exponent, and with every iteration I have to multiply my exponent by 10. Okay, I have not written the array here. 100. So these are the exact numbers that we took during our dry run. Let's see if we are able to sort them. 0, 1, 7, 7, 8, 10, 22, 31, 98, 100. So they are in the sorted form now. This is how the Radix sort works. It's quite interesting that how we could sort these numbers in a very efficient manner by extracting one digit at a time from the right. We also saw how we improvised on count sort and built a function which is uh, more efficient and does not require a lot of memory as well. Thanks for watching.